What's up guys? Eric, owner of Verus Engineering here.
And I'm Matt, and I'm the head engineer.
Is that good enough for you?
How come you got down off your stool?
Do I need to do it again?
I was like, why does this guy keep changing heights?
All right, so what are we saying? What we're looking at is the first pre-production, hopefully production model of the machined pan for the FA24 with 1.3 liters increased volume. So we have two baffles in front of us. Matt has a simplified version. This was based off of a Japanese paperwork that did a ton of research and development on oil starvation, but they did not have our oil pan. They had, I believe they just did the factory pan, correct?
Yeah, they started with it. It was for development of the 24-hour WRX. So it's a little bit not apples to apples, but it was a really good paper.
So we developed two baffle plates that basically bolt into that oil pan. One is wide open, one has some louvers. We are going to probably test both. We're hopeful that one or maybe both will actually be a large improvement. And this basically keeps the oil on the lower half of the pan. So we have a pan and it bolts on like that.
And the reason for the different, like the louvered version versus the wide open version is for oil drain back. So it's great to keep the oil down low in the pan, but at some point you need to allow oil to return back to the pan. So we need to kind of find a balance that lets a lot of oil flow back into the pan, but doesn't let oil slosh up and away from the pickup under cornering.
This is notoriously an issue with flat engine vehicles. Subaru specifically. Porsche seems to have figured it out. Subaru not so much.
The only reason the pan is in two pieces is because it's not machinable otherwise. There's some pretty massive undercuts to get bigger volume and you just can't really get in there with a tool. So we designed it as one piece, sectioned it, and then it gets welded back together after the two pieces are machined.
We are planning on casting this in the future, but before we can cast it, we have to prove that it actually functions better than what is actually the second revision of the machine pan, because the first one was basically an OEM pan, like 0.2 quarts larger, and then we had a little bung for silicone pickup, but anyways, that's beside the point. So realistically, it's machined right now to keep our costs lower on a prototype piece. In the future, it will be cast. We have some data, not a ton, but some data from Brian and the second version of this machined oil pan. It wasn't as close to the header in so many locations, but it was close and he was not able to run the heat shield. What's happening is you have an air barrier between the exhaust, which is extremely hot, probably 12 to 1400 degrees Fahrenheit, and the oil pan, which is probably around 220, 240. So that air barrier, first off, is a very good barrier. I don't know if people know, but air is actually really good at resisting a change in temperature. On top of that, you probably have some airflow going on around here, which is keeping airflow past the pan cool. What I'm trying to get at is Brian did monitor temps and he noted basically no difference in oil temperature. He does have an external oil cooler and that's going to be shedding way more heat than a header is putting into a 4mm thick machined pan. So that's where we're at currently. We do have gold foil. Gold foil is going to be used on the pan to reject some of that heat, but ultimately we're not that worried about heat. Heat management is something we can solve for. Oil starvation is what we're trying to solve for right now. Oil pressure prioritizes heat, so that's ultimately what it comes down to. I would almost say that anyone that's tracking the GR86 competitively or hard is already running an oil cooler, and if they aren't, they probably should look into one.
So with this version 3, I guess we'll call, of pans that have actually been produced, we've done a small production run. So we're gonna kind of bring a few more people into the testing at this point.
I believe Tor Anderson, which is another guy that's been working with us, is going to be testing this next iteration in California, and then we have probably a handful of other guys that have reached out that are interested in running this machine pan. This machine pan was very expensive to produce in this low quantity. We are offering them at a very deeply discounted price to those guys in exchange for data and testing. The oil pan was designed to have this, it's a -6 bung. This -6 bung is in the same location as factory or close there in, so that you can undo that metal plate underneath the engine bay and get to the oil to drain it. As far as the header, we specifically designed it around the OEM header because a lot of these customers are carb compliant, or they're running in a series where you cannot change the OEM header. This is EPA compliant. An aftermarket header is not. So that's why we developed around the OEM header. You don't have to change your header. You don't have to buy a header. You don't have to be illegal. This is the best option, and that's why we developed it around the OEM header. At the end of the day, we're gonna try and produce products that you guys wanna purchase. That's what we do here. That's why we enjoy what we do. So if there's enough interest in a specific header and we get a sample header of that, we can design something around it. But going back to what I just said in the previous question, hopefully Alex puts it in order. I don't know. I'll try. This header, the factory header, is carb compliant. It is legal. Keeping the factory cat is something that we wanted to ensure we were able to do, and that's why we developed it in this fashion, how we did it.
Yeah, and if someone is making a header that has a somewhat similar to factory routing, it might be easy to kind of nudge things around a little bit and make space for it without losing a significant amount of volume. But yeah, we won't know until we know.
Yep, and it'd probably be best to get us a header if you want us to test fit it sooner than later, because as soon as we start casting these, it's gonna be a lot more difficult to change the design. Once we start casting, we order tooling. Tooling is expensive. We have to cast, and that casting is what it is. It's not like it's a machined part where it's kind of easy, quote unquote easy, to change the program and machine in different pockets. Once we start casting, it's very expensive to change that casting. Yes. If you want to send us a header or you want to discuss this project with us, send us an email, sales@verus-engineering.com. We continue to push this thing forward, even though I shouldn't.
Hey, someone could send us a 3D scan too. If they've got the ability to scan their car with the header on, and ideally scan the header off the car as well, so that we have...
We should be able to do it if they just scan the header off the car, because we can align the flanges.
Yeah, that's true. Yeah, so if someone can, if someone has the ability to scan their header as well, send us a scan file, and it shouldn't be an issue to put it in our model and check. Slaps top of pan. You can fit so much RTV in this bad boy.
Damn it, Colin. All right, guys, so at this point, we're gonna conclude this video. We have to weld up the remaining 9 pans so that they can get shipped out to across the country and potentially world to test. Feel free to keep the questions coming. Alex loves them.
Good.
I had to put it in there. I don't love them. Until next time, I'm Eric.
I'm Matt.
We're out.